interface can be as rough as you want almost, and the material will still have these metallic states. For example, you have very, very good electron transfer, then you could try to use that to build a material where you have lower than in another kind of electronic device. So now thinking about actually small stuff, because you cannot really have a brick of a topological insulator that's easy to fabricate. But if you have a very tiny material, you could think that you can actually transfer electrons from one wire to another wire very efficiently, because these edge states are very much protected. So I had some experience with graphene and superconducting materials, and we tried to actually understand whether we could use topological properties, actually make those materials topological. My PhD started like that. And it kind of course, it changed a bit on the way, but I was still studying graphene in combination with the time. So yeah, most of my PhD was just studying these nano or mesoscopic devices made of graphene. So for those who don't know, graphene is like the graphite that we have in our past is just a stack of many sheets of carbon. I don't think we'll have quantum computers available as our personal computers anytime soon.
Wow,
And
it's fine. Best
yeah, so
scenario. Antonio, we are doing best case scenario.
I know, but I'm just trying to be slightly realistic. Sorry, I can also try to imagine a very idealistic thing, but just to give an explanation for people, it's just because you need very low temperatures to have a quantum computer. Like, oh, and we were talking about like minus 270 or 73 below the room temperature.
Mm, mm,
So it's very, very cold stuff. But well, say you have like internet access to a quantum computer, and then your cell phone can just be connected to a quantum computer. But I still don't know how it works, because quantum computers are good for specific classes of problems, and cell phones are built to solve another class of problems.
yeah.
So even in this case, I don't think necessarily that would mean computers running faster, but rather we would be able to solve problems that we're not able to, which I think is not as exciting for people listening, because it's not like you have a better computer, but scientists will be very excited about solving their own problems in this computer. And then the last one, I guess, would be a better open science culture in academia. I guess it's a bit more specific, because we do see people. I think open science became actually a big thing now in Europe, at least.
Mhm.
You can actually see that even to get the funding, you need to have some of the science plan for your research, and you have to disseminate this somehow.